In the last video, we learned how to do addition in binary. Next up is subtraction. Since it was helpful to first think carefully about how addition worked in base 10 arithmetic, let's begin with a look at how subtraction works in base 10. Here's an example, 326 minus 152. The way we learned it when we were kids is, first, just as with addition, write these on top of each other with the larger number at the top. Then go place by place and subtract only the numbers in each place. In this example, the first step is 6 minus 2, which is 4, and that goes in the ones place for the answer. But when we move on to the tens place, we have to think about what to do. We have 2 minus 5, but this is a negative number, and it doesn't make sense to put minus 3 in the tens place. So what we do is sort of the opposite of carrying from addition. We borrow. We borrow a 1 from the next place up and make that 2 into a 12. Now the subtraction makes sense. 12 minus 5 is 7, so we put that down in the tens place. The final place used to be 3 minus 1, but now it's 2 minus 1 since we borrowed. So the final answer is 174. What exactly is going on with borrowing? A lot of kids struggle with that concept, and it's no wonder. It feels like an arbitrary rule, but actually there's a basis to it. In addition, we sometimes have to carry when, for example, we added 4 plus 8 in the tens place and we end up with a number that's too large. We add 2 single digits and get something too big for a single digit, so we split it up. The 12 becomes a 10 plus 2, and we add 1 to the next place value up. Borrowing is just this in reverse. If the subtraction on a single digit results in something too small, we grab one copy of the next place value up and combine it with the current place. We say that we're borrowing a 1, but actually it's a 10 because it's one copy of the next higher place value. That 1 is 10 times the size of the digits in the current place. Subtraction in binary follows the same rules as subtraction in decimal, but the concept of place value is based on 2's rather than 10's. Let's see how this works with the example 1101 minus 110. In decimal, this would be 13 minus 6, so the answer should be 7. Lining these up with the larger one on top, in the ones place, we have 1 minus 0, so this is just 1, so we put that down with no extra steps needed. In the twos place, we have something to think about. 0 minus 1 is analogous to having 2 minus 5 in the earlier base 10 example. It doesn't make sense to put a negative number in this place in the result. And anyway, we haven't defined what it means for a bit to be negative at all. So to follow the same rules, here we are going to borrow from the next place up. But it's a little tricky. Borrowing reduces the 1 that's in the eights place to a 0. And although it says 1, it's from the next place up, so it's actually a 2, because the next place up is twice the size of the current place. In base 10, it was 10 times the size, but we're in base 2 now. So again, borrowing a 1 from here is going to put a 2, not a 10, here. Since a 2 goes here and we're in binary, we will write 1, 0, but remember, that's not a 10, that's just the binary for 2. So in our example, we have 1, 0 minus 1, which is really 2 minus 1, so the answer is just 1. Moving to the fours place, we have 0 minus 1, which is the same situation as previously. So borrow a 1 from the eights place, turn that 0 into a 1, 0, and subtract to get 1. There's nothing left now, so the answer is 1, 1, 1. And in decimal, that's a 7, which is what we were supposed to get. Now that's tricky, so let's recap. Just as in regular base 10 subtraction, binary subtraction goes one place at a time. If the single bit subtraction can be carried out normally, if it's 0 minus 0, or 1 minus 0, or 1 minus 1, then do so. Otherwise, if we have a 0 minus 1, we borrow from the next place value up. Borrowing a 1 from the next place value up is actually borrowing a 2 or a 1, 0. Just as in decimal, borrowing a 1 from the next place value up is actually borrowing a 10. Now we can subtract. Continue this process until we reach the end of the digits. Let's do a more complex example. 100,101 minus 11111. In decimal, this is 37 minus 31, so the answer is supposed to be 6. Let's go through the process. Starting with the ones digit, it's just 1 minus 1, which is 0, and no borrowing is necessary. Moving to the twos place, we have 0 minus 1. Like we said, we need to borrow a 1 from the next place up. So this 1 that's in the fours place becomes a 0, and it's a 2 or a 10 here in this place. Now 10 minus 1 is 1, and we're done with the twos place. So move up to the fours place. Because we borrowed, the fours place now has 0 minus 1, so here we are again. What we should do is borrow a 1 from the next place up, but there's nothing there. It says 0. So we have to keep looking in this top number and move up the place values until we can find some place from which we can borrow. The 16's place is also a 0. We don't encounter a 1 until the 32's place. So there's a chain reaction here, borrowing a 1 from the 32's place to have a 10 in the 16's place. But we also have to borrow a 1 from the 16's place to give a 10 to the 8's place. This reduces the 10 to just a 1 over in the 16's place and adds a 10 in the 8's place. But then borrow from that to give a 10 to the 4's place like we originally needed. So the 8's place is now a 1, and the 4's place is now a 10. Subtraction can proceed as usual in the 4's place, since 10 minus 1 is 1. Now move to the 8's place. We have 1 minus 1, which is 0, without borrowing. The 16's place is the same, and the 32's place is now entirely 0, so there's nothing to do there. We end with the number 110, and that's a 6 in decimal. Remember, that's what the answer was supposed to be. This example was quite tricky because we had to borrow from multiple places before subtraction could take place. This happens in decimal subtraction too, and it's just as tricky, like when we have 3,104 minus 731. In this problem, the ones digit is no problem, but in the tens digit, we have to borrow a 1 from the hundreds place, but then we have to borrow another 1 from the thousands place to be able to give to the hundreds place. So in this video, you have extended your skill set to include subtracting binary numbers and not just adding them. That was tricky, so congratulations. Next up is multiplication.